There's an object. I'm not going to tell you what the object is because we don't care what the object is. But that object in there is taking up that much water. We say it's displacing that much water. Hey, gang, if you weighed that much water, you got a value for it, okay? How would that compare to the buoyant force that acts on that unknown object? Begin with SS. Same, okay? In fact, the weight of water displaced is going to give me an upward buoyant force. Now, let's suppose this object happens to be a baggie filled with water. Then how heavy will it be? And turns out it'll be just as heavy as the buoyant force. So you know what it does? It doesn't sink. It doesn't float. It just remains at one with the water because it has the same mass as the same volume of water, which is to say it has the same density. So if something has the same density as water, it's not going to float, it's not going to sink, it's going to do neither. The density of water is 1 gram per cc. 1 gram per cc, or 1 kilogram per liter, or 62.4 pounds per cubic foot. That's the density of fresh water. I got a question for you. Is there anyone in here that happens to know the numerical value of density for a freshwater fish? Check your neighbor. Any buoyant force in a fish, gang? Show me a fish with no buoyant force and I'll show you a fish in a vacuum. Okay? A fish is displacing fluid, usually water if it's healthy, right? And so there's a buoyant force acting upward. Any gravity pulling on that fish? Oh yeah, and that's pulling down. Guess how hard the gravity is compared to the buoyant force that's such that the fish stays there? Come on. Same. So what's the density of the fish?
1.
The same as water. So if I tell you water has a density of 62.4 pounds per cubic foot, then you guys know what a fish density is in cubic feet. 62.4 pounds. Okay? Guess what your density is? More or less than 62.4 pounds per cubic foot? More or less?